Okay, today I'm going to make myself a drain valve for my Mini because Minis don't come with any kind of coolant drain. So I got two pieces of aluminum, one aluminum pipe and another piece of solid aluminum that I've got to cut and weld onto here. And we're going to carry on from there. Now I found a hole saw, or I have a hole saw that will make for the size of that pipe when I cut this down so that I can weld it on. That won't work entirely well. Let's switch it over to the drill head. Reached bottom. Gotta readjust that. Could have spent a little more time getting that centered, but we're not too bad. You can see it's a little taller, not quite centered. A little bit of file work so there's not quite so heavy a gap because the hole saw was not quite the same diameter as the pipe. And some file work, and it fits a lot snugger and quite nicely centered. There won't be a lot of fill area for welding, which I will do next. Actually, before I fill, I have to put some lands on here to make the pipes, the radiator pipe, seal a lot better. nice read. And as I say, it gives the rubber something to grip to. And with both sides done, I can carry on to the welding portion of it. Alright, welded it all up. I don't have the equipment to show you the actual works of welding, but then there's hundreds of other videos out there that do that kind of thing. So now we've got to get on to the next stage, which is working this portion in the lathe. Setting it up for centers can be a bit of an issue because it might not be perpendicular that way or that way, so it takes a little bit of centering to fooling around to centering it. Let's get on with that. Now what I'm doing here is I've got a piece of printed 3D printed plastic that I can put underneath to stop this from entering into the slotted areas, and also gives me something that I can shim to, which I will probably need. First I start at a lower shoulder and then move back so that if it's not perpendicular, then I will notice something's amiss here and we'll have to probably tap it a little bit to, or move it a bit to squeak it back and forth. And already that's climbing a lot, just moving it back and dropping below zero on that end. Supposedly within a thou. There might be a little bit of wobble in there, but that's tolerable for what I'm doing. Going for a 1/4 inch hole through. And that will act as the drain hole. Now I have to make a step in there so that a rubber grommet or whatever I choose to use will actually seat when you screw something in. Screw in the drain plug that I'll have to build too. it's giving me about 17 mil approximately between this land and this shoulder. So I'm going to take it down to about 16 mil. I decided on 15 mil because I do have to compensate for the pointy edge in order to flatten out a proper surface in there later on. Oops. And that was a 3/8 drill, and now I'm going to use a 10 mil end mill. 10 mil end mill. Yeah, say that a few times fast. And then going 16 mil with this should give it a reasonably flat land. Now using the 10 mil mill gives you okay, I forgot to show the tapping portion. I didn't turn the power on. So anyway, I tapped to a 7/16 by 20. So that's this portion done. We'll move on to the tap. See if we can see the land in there. Ah, there it is, way down there. And the hole goes clean through. Okay, we shall move on now. Now the design theory behind this is you got your through pipe or through flow, and then the 1/4 inch hole and a seat area, and your threaded section. And when you put your valve in there, it will butt up against probably an O-ring, and when you back it off, water will flow through there, around and out through your valve this way. Besides, that's the theory, and it's probably recording upside down about now. But you get the general idea. Okay, I found myself a piece of 1/2 inch aluminum rod. So we'll get that dealt with so we can make a plug for it. And going from the depth of the plug I need will have to be a minimum of 16 mil. I'll give it 17 just for the extra bit of cranking. Which at first we have to take down to 7/16 for threading. The 7/16 I need 11.11 mil. .12 ought to be close enough to get a thread on. We spin it around to get the threads right up to the shoulder. Now basically that could be a plug as is if I cut it off, knurled it, whatever. But I don't want to have to remove the whole plug and have something that could get lost. So I want the plug so it opens and water drains by and through. So we'll have to carry on with that mode of operation. Okay, take that down to a 9mm. Just guessing at this point in time. I got nothing real solid as far as that goes. Okay, that's seriously dull. I'm going to have to go sharpen that. Be back in a bit. Okay, go into a depth of 22mm on a 1/4" drill. Now, for the fun part. Yeah, I'm going to pop a 532 hole through that. Don't know if that's visible, but now you have a hole clean through. So the water will, once you undo it a bit, the water will come around, go into the hole, and out the bottom. At least that's the theory. Now I'm going to seat a small O-ring in there, and that should shut off the flow when it's fully closed. Now we'll just hook it up to a hose and see how it works. That's before I bother trying to figure out what kind of either knurling or wrench shelves, whatever I'm going to do to make that more friendly to grip. Forgot to mention on a side note here that I put a screwdriver slot into the plug itself. It turns quite well finger tight, but just in case on a later date it decides, I don't know, aluminum corrosion or whatever, you got a screwdriver slot that you can get a little extra torque on it. Now I took it and leak test, or put a couple of pipes on so I could leak test it. It didn't leak, that's a good thing. But I found that you'd have to take this down a little bit and get a thicker washer, otherwise the drain flow is not overly quick. The plus side here, again, you can undo the whole thing, but the washer, the O-ring will fall out, so you'll have to watch for that. I don't know if I can find a thicker O-ring, but I'm going to use it as is for now. On a final note, I do realize that I could buy these things off of Amazon or wherever, but the idea of me having a bunch of tools was to stop from being a consumer or overly consuming. So if I can make it myself, good deal. You know, I've got time. At least I think I've got time. I am getting older. Anyway, that's a mini radiator drain. Hope it helps. Take care.